In the previous video we created the skeleton of our geospatial extension. In this video we're going to add the library that implements this algorithm and we will add it to the build system. We will also create a stub function that will wrap eventually the algorithm. I have prepared all the algorithms that we're going to need in a zip file, which we will extract in a new directory called lib. This is a fairly common thing to see in extensions. I will first download the file and store it in the temp directory. And now I will extract the tar file here. This creates 4 files. The 2 C files in here we need to add to our config.4 file so that PHP's build system knows to compile them. You can add them to the end of the list of files here. The rdp.c file contains our algorithm and the geo_array.c file some helpers that make it easier to glue our PHP extension with this algorithm. I'll save the file and then run phpeyes again. Every time you change config.m4, you'll have to rerun phpeyes and configure. And then make again. In the output, you see that a few other files are now compiled as well. Here's the GeoArray one, and here's the rdpc file. Of course, our extension still doesn't work. Let us add these new files in a commit to Git, and then we'll create our stub file to do something here, so that we have an actual function and the extension compiles. Unfortunately, it seems that I've also created the dep files, which I don't need, so I'll remove them and then amend my commit. These dep files are created automatically by PHP's build system. Now let's create a stub for our function. At the moment it is empty. The name of our algorithm is RDP. And it is going to simplify an array of coordinate pairs. Let's call our function rdpsimplify. It accepts an array of those coordinate points The algorithm also takes in an argument that configures how smooth the line is going to be, or rather, how many points it should discard if it decides that they fall out of the required simplification. We saw that in the little video where I showed you how the algorithm works. If we remember, this was called epsilon. rdpsimplify returns then the simplified array of coordinates, so we can specify that in a return value. Most of the time, functions defined in extensions are prefixed with the name of the extension. In this case, that would be geospatial. However, this is quite a cumbersome name, so I'm not going to do that. Instead, I'm just going to leave rdpsimplify. I will save this. And if we now type make, it should create this new arcinfo file with the definitions. And the extension should then compile. I made a typo in the subfile because I forgot to use the function keyword. Let me try that again. And as you can see, the extension indeed compiles. Let's run make test though to see what happens. I am getting an error message here. If you look carefully, it says it is unable to load the library geospatial.so, which is what we've just compiled, because it says there's an undefined symbol, a ZIF RDP simplify. The ZIF stands for Zend internal function, and RDP simplify is the name of the function. It basically tells us that although we have defined that a function exists, we actually haven't implemented it yet. So let's implement a very basic function, basically just the header, so that the extension then finally compiles. We do that in our geospatial.c file. Now exactly where in the file you put these things doesn't really matter. I will add them to the end. If we open up our argvinfo file, we actually should find the definition. This is the definition that it has created. So I can copy that over and make sure that it is not just a declaration but an actual function. Of course, this function does nothing, but that's okay for now. I run make and make tests. And now our extension passes. This is another good step to add our new changes to Git. I like using git add p to see what my actual changes are and then can say that whether I want to include them or not. Do I want to add our empty function definition? Sure. As well as the stub and the generated information in our argvinfo file. And I will commit that. Commit not add. If I run the function on the command line, it will still do something strange. Before I can run it on the command line, I will probably have to run make install that copies the compiled extension into the standard extension directory. You might have to do that as root. On the command line, I can run a script. I use PHP. I now have to load the extension because we haven't added that to PHP ini. That's on purpose for now, because we're just being experimental. So we load the extension here, and now we can run a script. I'm just going to write up the results. Now the function took in an array. I will use an empty one and an epsilon, and I'll just use the values .01. This is just, of course, for demo practices. Now when I run this, let's see what happens. So it actually gives us an error, which is useful because it says the return value must be of type array, but instead we returned null. Well, actually, we didn't return anything because the function is empty. But PHP will make sure to enforce the return types that we have defined. So if we want to satisfy that, we also need to make sure to return an actual array in our return value. You do that by setting the predefined return value to an array. And I'll get back to it, what other things you can do with that later. For now, we just get to call array init return value. I will now compile this again, install it, and run the same script. And now we get indeed the result that we sort of expected, which is an empty array. This is another good step to add to Git. In this video, we imported the algorithm library into our extension and implemented a stub function that will wrap it eventually. In the next video, we're going to implement this RDP simplify function. If you enjoyed this video, please consider subscribing. Thank you for watching, and I'll see you next time.